In the next series of videos, I'm going to walk through the final exam review for Algebra 2. As I mentioned in class, when you look at the very end of this handout, there is a collection of solutions to odd-numbered problems. I want you to use those as a guide while completing the odd-numbered problems on your own. As you run through the process, you should be able to obtain the same answers that are listed here. Through this next series of videos, I'm actually going to walk through every even-numbered problem so that you can get an idea for the approach that I'm looking for. And you should also recognize that for each of these even-numbered problems, there is a similar odd-numbered problem associated with it. So I feel that if you can understand the process after viewing these examples on the right, then you certainly should be able to complete the other examples on your left. If more questions persist after watching and participating with these videos, by all means send a message to me through Schoology or by email, and I'll try to help you out. And since there really isn't enough room to do your work on the handout here, I would like for you to complete your work on a separate sheet of paper, or several sheets as needed. I think lined paper would be the best way to go. So here we go with number 2. We've got the expression 5 times 3n minus 2. The beginning of this review is just meant to confirm your understanding of distribution. So when we've got a single value on the exterior of the parentheses, we want to distribute it to all terms inside the first set of parentheses, and we do so by multiplying. So this is going to leave us with 15n minus 10 as a result. And not a whole lot of work needs to be shown for this particular example. Similarly with number 4, not a whole lot of work needs to be shown. We just simply need to recognize the distribution must occur where the number on the exterior of the parentheses must multiply by each element on the interior. With number 6, on the other hand, the distribution isn't quite so straightforward. There's a pair of distributions that must be completed. So one set of distributions is going to be this first term, 5r, times each term in the second group. And then we need to multiply the second term of the first group by everything in the second group as well. So there are actually 4 multiplications that are being completed here. Most of you recognize this as the FOIL process, and that's a nice technique for you to keep track of your work. In any event, I suspect 2 or 3 lines of work would be appropriate here, because in this first set of multiplication, 5r times 2r leaves us with 10r squared. Then the outside multiples produce negative 20r. The inside, 5 times 2r, is 10r. And then for the last multiples, 5 times negative 4 is negative 20. But this can't be our final answer because we do have 2 like terms that must be combined. While the 10r squared has no like terms and the minus 20 has no like terms, at least these 2 in the center are alike one another. They can be combined, and negative 20r plus 10r is negative 10r. And this is what leads us to a good and final answer for number 6. For number 8, I think the same process would be appropriate here. The first 2 terms in each binomial multiply, whoops, gotta make sure my letters match here. But again, the first 2 terms multiply to make 20k squared. The outside terms multiply to make 25k. The inside terms multiply to make negative 12k, and then finally our last terms multiply to make negative 15. Because there are like terms in the center, those should be combined, and positive 25k take away 12k leaves us with 13k, and the 20k squared and the minus 15 have no like terms, so we'll leave this as our final answer. Please keep in mind that I'm looking for your work as much as I am for looking for final answers in this upcoming exam. So make sure that you leave evidence of your solution at all times. And when we get into problems like number 10 and 12, the foiling process technically breaks down, although in general it works okay. The problem with foiling is that that's only good for when binomials multiply by binomials, or two terms times another two terms. In this case, we've got a two-term polynomial times a three-term polynomial, so there are actually 6 multiplications that must be completed in order to finish this distribution. So if we follow this process one by one, this 4x must multiply by the 4x squared, and that's going to yield 16x to the third. Then this 4x multiplies by the next term, which is just x. And that leaves us with 4x squared. Then the 4x multiplies by the 5, which leaves us with 20x. And that's going to complete the first round of distribution, everything from the first term inside the first polynomial multiplied by everything in the second polynomial. And now we'll move on to the next term. So negative 1 has to multiply by 4x squared, so that's minus 4x squared. Negative 1 has to multiply by x, which is negative x. And then finally, negative 1 has to multiply by 5. As we saw before, this answer is okay, but still not the best, because we do have like terms that should combine. In this case, it's kind of interesting that 4x squared minus 4x squared will combine, and those will equal 0. So a lot of times you'll see us cross these out because they're essentially canceling with one another. Another pair of terms that are going to combine because they are alike one another is the 20x and the minus x. So positive 20 take away 1x is going to be 19x. The 16x cubed and the minus 5, the beginning and the end, don't have any like terms to combine, so we'll leave those as they are. And again, we have 19x in the middle after we've combined 20x and negative x. So this would be a good result. With a problem like number 12, we can complete the same we can complete the multiplication using the same process as before. But the problem with that is that there are going to be lots of arrows or lots of these arches that are going to be drawn on your paper if you show those, and it could be a bit confusing. Another option when multiplying large polynomials, and generally I reserve this technique for 3 or more terms times one another, is to create a chart or create a table of multiplication and complete your work that way. So this first polynomial I'm actually going to list in stacked form. I'm going to call this 3n squared, 5n, and positive 1 here on the left hand side, and then across the top I'm going to rewrite 3n squared, 3n, and positive 5 as well. What I'm going to do is I'm going to create a box or a grid. I'm going to complete all of our multiplications within this box or grid rather than showing all of the arrows in between. Because again, 3n squared was supposed to multiply by 3n squared, but we already have that layout here in this grid. When the column and row intersect, that's going to indicate a product of two sets of numbers. So 3n squared times 3n squared is going to be 9n to the 4th power. From here we would have moved on to 3n squared times 3n, and we see that again in the chart, 3n squared times 3n, where the row and the column meet. We'll go ahead and multiply those together. And this makes 9n to the 3rd power. If I continue multiplying through the chart rather than worrying about the arches that were drawn, we'll see 15n squared in this box. In this box we'll have another 15n squared. Sorry, that one's 15n cubed. 3 times 5 gives us 15, but n squared times n gives us n cubed. Here in the middle, we see 15n squared. And at the end, 5 times 5n is 25n. For the bottom row, 3n squared times 1 is 3n squared. 3n times 1 is 3n. And 5 times 1 is 5. So this box contains all of the terms that would be used to create our final answer. And you might recognize that across these diagonals we end up seeing like terms that can be combined together. And so here's another benefit for completing our multiplication in grid form like this. Most of the time, like terms present themselves fairly nicely in these diagonals, and that allows us to report our final answer pretty easily. 9n to the fourth power has no other like terms. 9n cubed and 15n cubed, those are going to combine together to make 24n cubed. And I'm just putting a little x in each corner after I use each term. 15n squared plus another 15n squared is 30, plus 3 makes 33n squared. Then 3n and 25n makes 28n. And then lastly, the number 5 has no other like terms, so we will report it at the end. And now we've obtained a nice, correct final answer.